Friends, I am going to discuss the third solution of the sliding dumbbell problem from the famous physics book Pathfinder for Olympiads and JEE Advanced. Two solutions of this I gave already in my previous videos. Now I am going to discuss the third solution. Anyway, for the sake of new viewers, I shall tell the problem first and go to the solution later. Two identical balls, say A and B, are attached to the ends of a light rod. This is a smooth wall, it is a smooth floor. This rod system is leads from the vertical position, initially just descend to the wall, leaning against it. It is slightly disturbed from this position to slide between the wall and the floor. The question is, when the upper ball leaves the wall or about to leave the wall, what is the velocity of the lower ball? So at some general instant, theta, when the rod is inclined at theta with horizontal, I want to find the normal force given by the wall as a function of theta. So then it is over by equating nx equal to 0 as given, means the ball is leaving the wall. So nx is 0, I solve for theta value. So in this solution I am trying to find the normal force itself as a function of the inclination of the rod with horizontal say theta. Let us draw free body diagram. Its own weight mjx downward, normal force say from the floor nyx upward, of course tension from the rod say tx on the wall in this direction. For this ball again mjx downward, its weight, normal force from the wall say nx in this direction, and again tension in the rod x in this direction. What is the acceleration of the center of mass of the system? Net force by total mass. So I am writing two accelerations of the center of mass, horizontal and vertical. So acceleration of the center of mass in x direction, am I right? Net force in x direction, external force, only nx. Tension internal forces, remaining forces are vertical. So only nx by total mass of the system of the both particles m plus m 2m. Next, acceleration of center of mass in y direction, am I right? Net force in the vertical direction, external force, mg plus mg and ny, that is mg plus mg 2mg minus ny by total mass 2m. So horizontal acceleration value nx by 2m, vertical acceleration value, am I right, g minus ny by 2m. Now what is the direction of acceleration of this one? Vertical. That is the basic idea I am using. It is moving vertically, so its acceleration is vertical. So its acceleration in the horizontal direction is 0. Now, how do you find the acceleration of this one? Acceleration of this in the center of mass frame plus acceleration of the center of mass. Acceleration center of mass we have anyway found. In the frame of the center of mass, how do you find acceleration of this? In this frame, just it appears rotating like this. So it has a tangential acceleration r alpha and the centripetal acceleration r omega square. So I have to find omega and alpha basically. How do you find omega? So by applying conservation of energy, we can find omega value. Let's see. Initially, rod is like this. Now rod is like this. For this ball there is no change in potential energy as moving in the same horizontal level. Only this ball is falling. So decrease in the potential energy of the system means that of this ball I am writing mg into fall of this ball is L minus, what is this value of this? Opposite side is L sin theta. L minus L sin theta is equal to half I omega square I am writing. Kinetic energy of the system. I is the moment dimension of the system about axis of rotation. Axis of rotation you can find easily. Its velocity direction is this one. So drawing perpendicular to this, you will get one radius. And velocity of this is downward. So drawing perpendicular to this one, you will get another radius. Intersection of these two radius itself is the axis of rotation. We call it instantaneous axis of rotation. Now let us write moment of inertia about this axis. Only for two particles you have to write. This particle is rotating in the radius. I mean distance of this particle from the axis is this one. That is L cos theta. So you can write mg, take L common, 1 minus sin theta equal to half. For this particle moment dimension of mass into its radius or distance from the axis L cos theta whole square, plus for this particle mass into its distance from the axis, this is L sin theta whole square into omega square. So this is half ml square I am taking out. Cos square theta plus sin square theta is 1. So half ml square into omega square is mgl into 1 minus sin theta. So now by cancelling m and l from both sides, you will get L omega square value. So by cancelling m and l and take 2 this side, what do you get? 2g into 1 minus sin theta. 2g into 1 minus sin theta equal to L omega square. M and L and ML cancelled. Now I want to find alpha value by applying torque equal to I alpha equation about the same axis of rotation. About this axis, if you apply a torque for mg, for ny, torque is 0 because they are passing through this. For nx, torque is 0 because passing through axis. Only for the weight of this particle I have to write the torque. So for this, torque I am writing force mg, perpendicular distance is L cos theta is equal to I value already have seen this value, that is ml square. So from this I got the value, again cancelling m and l from both sides, I got L alpha value g cos theta. So now you see acceleration of this particle is vertical or in horizontal direction it is 0. That is what I am using. Write acceleration of this. Acceleration of this I am writing as acceleration of B is acceleration of B in center of mass frame plus acceleration of center of mass. They are all vectors. So what is the acceleration of B in center of mass frame? Let us see. In the center of mass frame, it is at rest as we see and it is rotating. So the radius in which this ball is rotating about center of mass is L by 2. So it has a centripetal acceleration L by 2 omega square and it has a tangential acceleration L by 2 alpha, I am writing separately. Acceleration of B is L by 2 omega square is centripetal acceleration. Tangential acceleration is perpendicular to this. L by 2 alpha. This is what ABCM bar part. Acceleration of B in center of mass frame is these two vectors. Plus ACM bar is, we have seen already these two vectors. That is nx by 2m in horizontal direction. Next, G minus ny by 2m. Now you see, sum of all these four vectors is the acceleration of B. Angles are clearly, so this is theta, this is 90 minus theta, and this is theta. Because the direction of the acceleration of this is known, that is downward, as it is moving along the wall downward, I am writing acceleration of the ball in the horizontal direction 0. What do you write? You see, in this direction there is already nx by 2m plus component of this in this direction L by 2 omega square cos theta must be equal to component of this in this direction L by 2 alpha sin theta. This is anyway vertical, it has no components in the horizontal direction. So L by 2 alpha component, L by 2 alpha sin theta. So this is what the condition for acceleration of the B in horizontal direction 0. So now cancel to all sides. Nx by m value L omega square cos theta. L omega square I have derived as 2j into 1 minus sin theta. So it is L omega square plus 2j into 1 minus sin theta into cos theta is equal to L alpha value, again we have derived as g cos theta. L alpha value g cos theta into sin theta. So I got nx by m value now. Taking it this side, g is common. Here sin theta cos theta. Take this side minus 2 cos theta. 2 cos theta is goes that side, minus 2 cos theta. Minus 2 sin theta cos theta goes that side, plus 2. So finally the expression for nx is mj into 2 sin theta cos theta plus sin theta cos theta, 3 sin theta cos theta minus 2 cos theta. So as per the given condition, when ball leaves the wall means nx is 0. So just by equating this expression to 0, we can solve for the theta. So now by equating nx 0 implies cos theta is a common factor. So cos theta equal 0. This implies theta equal to 90 degrees. At theta equal to 90 degrees means at the moment it is released, normal force from the wall is 0. It is vertical, you see. Entire weight is balanced by the normal force from the ground, that's all. Now another solution, after taking cos theta out, 3 sin theta minus 2 equal 0. This implies Sin theta equal to 2 by 3 is the angle where the ball leaves the wall. So once you got the theta value, you can write the velocity, because the question finally asked is to find the velocity of this ball. How do you write the velocity of this ball? Simply I am writing r omega. Radius of rotation of this ball from the axis is L sin theta into omega value. How do we write omega value? You see, from this I am writing omega value as omega square value 2g into 1 minus sin theta by L into omega value root of 2j into 1 minus sin theta by L. Now over you see, substitute the value of sin theta we derived. Sin theta value 2 by 3 and the root of g L by root L is root L into 2 into 1 minus sin theta value 1 minus 2 by 3. So this comes to be 2 by 3 root of 1 minus 2 by 3, 1 by 3 into 2, 2 by 3 dU. So friends, finally this is the velocity of this ball when this leaves. You see here, we have found normal force Nx as a function of angle itself. How is normal force varying? We can sense first easily. Initially normal force is 0. At sin theta equal to 2 by 3 also normal force is 0, Nx value. So from 0 to 0 it is moving, means normal force must have increased from 0 to some maximum value in between and then decreased to 0 finally. So we can find normal force maximum value. So I am leaving this to you viewers. As we know the Nx as a function of theta, just by taking derivative of Nx with respect to theta, we can maximize it. At what angle normal force becomes maximum and what is the maximum value of that normal force, I am leaving to your interest. Thank you friends.